Hi, I'm Steve Proud, and today I'm going to show you a video, and it's going to be about something that's fantastic, and you're going to learn a lot, and you're going to thank me for everything. Okay, so enjoy. 12:42 a.m. in the morning, excuse me, and I've got some time to kill because I'm copying some files, so figured a good time to do a video. And today we're going to talk about wiring, or not wiring, so we're going to talk about programming, setting up a CMMP-AS-M3. There's a variety of them size-wise. It'd be like an M3 dash. There's a couple. There's like 5 of them, and we're going to use EthIP to talk to a Rockwell ControlLogix or CompactLogix. They're all the same, and I'm going to use a version 23 project. And we're going to use an EDS file, and we're going to use the latest files that Festo offers on the website. So the first thing that we want to do is we want to go to the website. So when we get to the Festo website, if you type in festo.com, you would click on the support downloads here, and you end up where we are right here. So type in the product, CMMP-AS, and then select. I'm going to choose this one today. And when you're finished doing the search, we want to go to the software tab. First thing we're going to need are the function blocks for the PLC. So we're going to use version 2.3, and it's good for these controllers here: CMMP-AS, CMMP-ST, and CMMP-M3, M0. Click the file, and we're going to download that. We'll let that download. While that's downloading, we'll get a couple other things here. The Festo Configuration Tool, which we'll use to configure the controller itself, will be this version right here. I'll pick today, and you download this and then install the exe file. I've already got this installed, so I'm going to ignore this for now. The next thing we want is going to be the EDS files, or the EDS file. So this one right here, we're at a version 1.3, and it's important to look at the firmware while you're doing the same thing here. So the firmware I'm going to be using is the latest on the site here. Got 4.01.15.01.2.3, and it has previous versions as well, but the key factor here is that this EDS file works with version firmware greater than or equal to 2.3. Okay, so make sure that we use that particular file. So download this. Okay, so I clicked on that and I downloaded the firmware. And okay, so what that downloaded was a zip file. This zip file right here, this EthIP. And within the zip file, you've got a couple directories, and like I said in the website there, we want this one right here. This one right here. Okay, well, so I'm going to take this and I'm going to unzip these files to the directory where I'm going to go later to get them. Okay, and that's that. So we keep going here. Next thing is to get the firmware. All controllers that are delivered from Festo and basically any other manufacturer these days come with no firmware or older firmware, so that you have to upgrade to whatever you need for your facility. So click on firmware, download the firmware, save it. What else do we need? Well, if you want to connect to the controller via USB, you need the USB driver, but I'll use Ethernet for that. So let's recap. We've downloaded the firmware for the controller series. We've downloaded the Ethernet IP EDS file, and we have downloaded the SCT plugin, and we've downloaded the function blocks or AOIs, add-on instructions for the Rockwell controller. Shouldn't be called function blocks, but I think Festo is a European or Siemens company, so they think everything's a function block instead of an add-on instruction like Rockwell calls it. So we've got all those files there. So let's open a project, a fresh project. So like I said, version 23. Start up a version 23 project here. Ignore the background. Come on, open. Okay, so the project's finally opened. We're going to select new. This is quite boring stuff, but for the sake of you guys, I'm going to do this. Browse to where I keep all my files. Okay, so selected my directory, give it a file name, selected the PLC, hit the next. And revision 23, 7 slot. Finish, good enough. And move this over here. So, need to add some modules here. So, turn this on. So, EN2TR. Six. I'm using an older rev here on purpose. I'm not going to tell you why, I'm just doing that. Slot 3. Connection, RS networks info, internet port, network time sync. Okay, so we added that card. And we've got a couple other cards, but that's the main card we need to focus on. So here. Now, close that. So we've added that. So the next thing we need to do is install the EDS files for the premium controller. So I'm just going to go select the bullshit firewalls things. Get rid of that. Yes. So give me my pop-up. Things are so quick these days on software, I tell you. Okay, next, register an EDS file. Now I'm going to browse. Okay, so I'm selecting the folder here. Hit the next button. It shows all the files here that I have in the directory. There's my path there if you want to really read it slowly. It doesn't matter, so you just put your path somewhere, hit the next, hit the next, hit the next. So I'm basically installing all of them, but I'm only going to use one, of course. But so we've installed the EDS files. That's how simple that was. The next step is to actually add the drive. Now, right-click on the Ethernet card because that's where we're adding it, and I'll try this. Ethernet, nothing there. So it's probably a Festo. I don't see it here. So let's just CMMP. Enter. Okay, so select everything. I don't know where it is, but it's in here. And we're going to add the smallest controller, C23AM3. So we're going to hit create. Give it a name. So on the front of the controller here, so you've got two. So when you buy the CMMP, you get this outer shell here, and you have to buy this card here separately. And then when you want a communication card, or there's a variety of cards you can buy, but you buy a communication card, put it in here. So this card here is, they call it a KMC FHPP, just like I'm writing down here. And I'm giving it EDS, so I'll call this Axis X here. And I'll be giving it IP address 45 later. And we're going to do 16 and 16. And we're going to do Sint. Okay. Yes. We're doing 16 bytes, and I'll show you later why. Okay, because it's a configurable. The controller itself is a configurable thing with relation to the size of bytes. Basically, the basic configuration has 8 bytes, and then you move into another 8 bytes after that for another standard area of data, and then beyond that, it's configurable as well, but very to the project itself. So let's look here, the requested packet interval. So 20 milliseconds. Well, you can go as low as 1, but if you're really doing something worthwhile, you probably don't want 1. So I'm just going to make this 5. Unicast you watch, Ethernet. So you don't want multicast because you'll just have so much traffic out there, it's not funny. Cyclic, change of state, that's up to the user. I like cyclic, that way every 5 milliseconds something's happened. Hit OK and close. So now I have this here in my tree, and it's talking via that particular card. Now if you were to go up to the controller tag, you'll notice here that it, or the software, populated your project with tags. So you have your 16 bytes of input, 16 bytes of output, and then you've got a couple nice little bits here, the run mode connected. You can use those throughout your code to make sure you're not trying to use or communicate when it's not even communicating itself. So you don't want to code something like that, and we'll show you that later too. Alright, so next step. So we've got the Ethernet card, we've got the EDS file added now, and we don't have any code, and we don't have any AOIs. So let's bring in the AOIs. Right click, new add-on instruction, or actually no, sorry, import add-on instruction. Wait for Rockwell to catch up. I just love the new software. It's not like I don't have 32 gig of memory and an i7 processor, and it's still slow. So I'm going to navigate here to the directory where I have my add-on instructions. Instructions, and you'll see here there's a variety. So there's control, and you'll see here that there's two versions of each if you in all the fields. I think basically Festo realized or thinks that the version 20 software needs a specific add-on instruction. So we're using version 23. So basically any version from 21 up, use the ones without the underscore version 20. So I'm going to bring this in here, say import. And it'll add user defined. I'm assuming I'm not even going to read this. I just always say okay. Come on, baby. So it just added all these data types, and it added a add-on instruction. If you were to look at this, it looks like this. You can go and look at it, but you don't really need to. The whole purpose of that add-on is that you don't have to do anything with it. So you keep importing all the add-on instructions. Is there an order of operations to do that? No. It'll take care of itself. So I'll do one more here, and then I'll do two more, and then I'll do the rest. So I'll do this one now. Import. And okay. Import. So quick. Data. Read. Alright, so I'm going to continue to do the rest. I'm just going to pause the video while I do the rest. Okay, so time flies when you're having fun, and I have imported all these AOIs. Okay, and the AOIs added these user-defined data types when it needed to. So hit the save button. It's always good to hit the save button. Verify the project. No project problems at all. No code. Okay, so at this point, we've got bare bones. We've got the building blocks. We've got the EDS file with a controller. We've configured an IP address for that, 145. We've got add-on instructions. The purpose of an add-on instruction in general is to kind of accelerate your project. And let's just talk a little bit about what that purpose is. So we downloaded the library, and the library, wrong one here. We downloaded the library, and when you unzip the library file, you get a couple of different things here. You get what we've just showed you. We've got the 3 directories here with all the add-on instructions, and you've got an example file, which is what we're creating. If you look at the example file, let's just open this example file up. Okay, so we've opened up the sample file that comes with the library, and you'll see here that they've also got the data, or the the add-on instructions, and they've done a sample for a couple of their different controllers. CMMO. So this one here, CMMP, would be closest to what we're doing here, or is what we're doing. And there's no descriptions or anything in here. They're just there's just some code. So they really didn't describe what they're doing or why. If you want to understand that and use their code, go for it. I'm assuming, or they have documentation, which is this documentation right here. It's all part of the library. Double click on this, and you'll see here that they're talking about their library. So I'm just going to close this right here and go into show you a couple of things in here. So this library documentation file actually does explain all of the things that I'm doing here. There's the pictures. So if you don't get what I'm doing here and you've still got some problems, perhaps you can go in here and look to see what they've done in here as far as explaining. I'm just showing you the basics about everything, and looks like they've done a pretty good job in here. I'll close that for now, and I'm going to go to my project here. So okay, so in general, the main routine is used to jump to other routines, and you don't use it for code. So I'm just going to do a new routine, give it a name, and use ladder diagram, say OK. And this is where I'm going to put all the AOIs that I want to use here. So close this tab, and we're in here. And in order to use an AOI, there's a couple ways to do it. So there's an add-on. You go in here and click on add-on. You'll see that all these add-on instructions are up top here. Even gives you a nice little version 2.3. So if you read the literature, you'll see that as a minimum, you need 3 function blocks to make the, or 3 AOIs in order to use the basics of the controller. And for that, we need an FML read. So double click on that. We're going to have that. Add another rung. We're going to need a FHPP control right here. And then one more is a FML write. And like any PLC, you do a read, execute code, and then do a write. So the write's always the last thing, the read's always the first thing. All of these instructions, they need to be scanned all the time. So don't put any code on these lines here, leave them on. The only code that should be here on these lines will be communication steps. So you don't want to play with code over here, just like in normal cases, if you're not communicating to the device. So we go back to the controller tags, go to the input. You can say, copy this, put a put a bit in here. You want to make sure that you're in run mode and that you're not faulted. And that should be the only code. All I'm doing is pasting, right? You know, you can do paste, copy, paste. I'm just using the keys over here. So as a minimum, and the only thing you want to do is the communication monitoring of the actual device that you're connected to. So whenever this goes off or goes down, these bits will transition and therefore stop your code. You might want to change that later so that at least the read and write happen, but you don't want to execute this. So let's do, well, I'll think about this after. So these are just bits that you want to use, and you can think about how you want to apply it to your system after the fact. Now, first thing we need to do is configure everything. So we need to give a name, add a data type. It'll select the data type already, put it where it needs to go in the controller tags, and we'll do a data ref, data types, and this one right here, paste that in there. Let's go a little bit closer. So this right there is, back to the tags, put on the data, it's that tag right there. So not the array, but this. And then we go back to this right here, the device type. So we're going to do something real quick here. I'm going to add a run comment. Okay, so this is the information I'm showing here is in the actual document that I showed you earlier, the library document. And it gives you some information about configuring this particular AOI. So the device type, that's telling this code or this AOI what, because this AOI is is meant for like 5 different controllers, as I've written up here: CMMO, EMCA, CMMP, CMMS, 2 different types. So CMMP-AS equals 30. So this one right here, we're going to put a 30 in. And we're going to be doing Ethernet IP today. So as I've got written here, Ethernet IP setup, Modbus is 0, high byte 0. So this one here is 0, this one here is 0, so that's good. And then we've got the starting address. The starting address is 0, because if you go back to your controller tags, that's where it is. So byte number 0 is where we're starting. And this one right here, I'm going to leave for a second. And what I'm going to do is I'm going to, okay, so this right here, I'm going to put a 1 in here. I'm going to come back and explain that later. And the starting address, I'm going to put an 8 because, as I kind of mentioned earlier, we've got 8 bytes is the first control area, and then the second control area for parameters is the next 8 bytes, and that starts at byte number 8. So if you go back to the data table here, we still 0 through 7, that's the first 8 bytes, and then 8 through 15 will be the next 8 bytes. And we're not using plus, and we're not using this, and we need a status. So I'll just create a tag for that. New tag, create, and that's one rung done. Okay. The next rung we're going to do is this one here. Put a comment in, and put a name in. Okay, to continue here, what I've done with my code is I'm going to add a couple of data types myself. So just bear with me here. I'm going to copy some data types in. So I would say import, but you're going to have this file when it's over, so I'm just going to say paste. Paste a couple of these ones in here. And Just for the sake of organization, I've made these. And then we've got, so those are generic ones, and then I've got this move data one, and then I've got a control one. And then what I need to do is I need to add some tags. So the idea here is that a tag. So controller tags, edit. I'm going to paste in this one here, this UD CMMP-AS control, and I have already got the FHPP control embedded in there, so I'm going to copy this over here, and that's what this is here. I paste, that's what that is. And this ref here, the FML ref, that's the same for every function block. So I'm going to copy this, paste it in there, go down to this one down here, paste it in there, because this data ref is what's transferring the data from reading and writing into variables which are passed between these function blocks. So the common data structure that communicates from tags in the project to the real I/O is in fact this one data reference here. So if you go to monitor this, expand it, you'll see here that you have all these tags in and out, and then you've got a bunch of other things that are part of the data structure. So we've got this. All we need is the name, or to instantiate this function block here, and the data ref, and we're good to go. Now, see how it's not zeros or anything like that? Well, that's because I copied the tag from another project, and there was already values in that structure. So I'm just going to leave it the way it is here. If we have to, we can come into here and zero everything. There. I could go and zero those ones too, but I won't. Those are status on the right hand side. So for the last AOI, we've got to do another name. There you go. Okay, right, create, and we need the old data, the output data. Again, if you go to monitor, so now we're dealing with outputs. So this is the tag I just put there. We're going to be starting with this byte 0 and then byte 8 for the next 8 bytes. So again, FHPP out is byte 0, FPC out is byte 8. And we need a status for that. New status. And good. And a little run comment in here. And just going to paste a run in here. I've got this little note in here, so I'll deal with that later. So right now, I've got the EDS file. It's communicating to address 45. It's exchanging 16 bytes of data. That's the access name. got main routine. Let's add a jump subroutine. So where is it here? Just type in JSR, and we're going to do a jump subroutine. So the main X, hang on, properties. So the main routine is what's going to be executed. Okay, and when it comes into here, we've got FML read, so it's going to read the data, bring it in, shove all the data into the tag reference of the data ref. When it's finished, it's going to write all the data out, and this FHPP control is how you basically manipulate the motor and get it to do things and so on and so forth. So this is the starting point. This is the minimum. Right now, if you download this to your controller and have everything else configured, which you don't yet because you still have to do the Festo Configuration Tool software here, you could basically, turn the enables on and start running it right from here. So I'm going to continue this. So we've downloaded the plugin, the Festo Configuration Tool plugin, which is the software that configures what hardware is connected to the controller and configures how the controller is going to react and so on and so forth. So we're going to create a project with that right now. So start up the software, select new project, give it a name, and the name is going to be something I copied already, so this is what I'm calling it. Basically, EDS is version 1.3, plugin version is that, and we're using AOI along with FPC. Okay, so create it. And now we select the controller, give it an access name. The version is the latest, which is what we've just installed from the web. Okay, creates a shell of a project. And then from there on, you need to configure it. So you come into here, you follow the little wizard here. And in my case, I've got an M3 controller, a C23A M3, option slot. Is empty. Slot 2 is the Ethernet IP card. This one here is safety module. Everything in this software is left to right. So this one here, I'm going to be doing a custom motor with access. Hit the next button. And we've got EMMS-AS, we've got a 55S, and TM, 55S, TM. It's an older type motor. Cable length is important because it uses that to modify settings within the project later on. Next button, linear axis. And we're going to have an EGC, which is one of the more common axes. Tooth belt, size 70. And we're going to have okay. And the stroke is 400 millimeters. The next button. So this is what our controller is being connected to. It's got the motor, and the motor's got this axis. You hit finish, and then it puts some defaults into the project. Are the defaults correct? No, it's up to the user to go through and make sure that the defaults are suitable for their application. So I'll let you do that. But basically, you can navigate by using this little Explorer window over here on the left. But if you notice when I started the project, there's quite a few plugins, and if you use Festo a lot, the plugins and this area over here don't necessarily match up all the time. Because when you turn on certain features earlier in the project, for example, if I turn this little position trigger thing on right here, it just added this over here. If I turn it off, it gets rid of that. So, depending on what you have, so the easiest way to navigate this software is to basically use the next and previous. That way you can't miss anything. So you start on the very first page, which we've already done, and then at this point you just hit the next button, and you look at what you're dealing with. So we're going to be using EthIP in this project. There's these features over here that you need to consider. At this point, I don't necessarily need any of them, because we're going to be using what they call direct mode. So FHPP profile is Festo handling position profile, and we're going to be using direct mode position to control the axis to go from point A to point B. And for that, we don't need a record sequence because we're not going to be using this record table, which you'll see later. We're not going to be using analog set point. We're not going to be using synchronization between two controllers. We're not going to be simulating the encoder. We've got no external measuring system. We're not using any position triggers, and store position we're not using. So I just hit the next button. And this one here, I know that my motor polarity is reversed. Need to put a load in. In this case, it's very, very small for me. And it's extremely important right here that you understand what your total load is, because right now it's going to modify all the gains for you, and it'll be a very closely tuned system at that point if you put the proper load in. So you say yes, it calculates the loops and updates your project. Hit the next button. Target reached. So you'd go into the catalog right now, look up what the achievable target is here, and you put this in, or you open up based on your application. Following year, again, application dependent. I'll let you guys decide what you want to do with that. And I'm going to skip forward here to this right here. So you've got a couple homing options. You got, and then for the homing options, you can use limit switches to help with the homing, and reference switches if desired. So you select normally closed or normally open switch types right here. There's some other limitations over here as well. The max here is lower than what is capable. It always does that. The items down here are extremely important, because when you drop the enable, for example, or you have a fault, it'll use these decelerations to stop the axis. So, for the sake of argument here, 555. Don't want to stop the axis too abruptly, could possibly damage some mechanics. And I'm going to put the max in for speed, and then we've got our things. Hopefully you're using normally closed, because that's fail-safe, if you know what that is, I hope. Now we get to the homing setup. So on the homing setup, in my case, I'm going to use the limit switch. So the limit switch is actually referring to the over travel limit switches, which are limit switch low and high in DIN 6 and 7. And I'm going to be going the negative direction. And the zero pulse is where you hit the switch, come off it, and then you start looking for the encoder, the one encoder pulse per the 360-degree rotation on the encoder. I'm going to just leave it like this for now. The next button. Right here, I'm going to make this 3.0. So I'm going to make a 3 millimeter offset, so that when it finds home and then moves off of the switch, it'll move 3 millimeters forward and then call that the zero position, which is what references all absolute moves from then on. And you don't really want to be close to the end stop or the limit switch and trigger the limit switch. And again, this is the The limit switch is actually the over travel. So when you're using the home and you're executing home, it turns off the functionality of the over travels and uses the switch that you've selected as the device for homing. So next button, go to 0 point afterwards, normal. We've got a -3 here, and we've got a 397 stroke. So these are the software limits, so that if you go back to where the limit switch is, basically, it'll stop the access. I'll put a 2 in there, so that you're not actually sitting on the switch. And hit the next button. Next. Don't need those. Don't need those. Don't need this. Defaults are good. This is the calculated gain settings that was based on your loads. Don't need that. It should have done that already. IO config. We're not really using IO. We're going to use the Fieldbus. So there's only a few signals in IO that you for sure need still, like the ones that are safety related, like DIN 4 and 5. And don't need to do much here with this, because this is assigning signals to, or functions to, the digital inputs and outputs. There's the outputs. Again, don't need that. And I'm skipping down. As you see here, it's following along here. And then we get to the Fieldbus. So now we're at the important part here. Like I said earlier, the module there's the CAMC FEP card down here, and then there's the X18 or X40, whatever the Ethernet card is up here, the built-in Ethernet port. So what we're doing right now is we want to set this card here as the 192.168.1.45. So in our project, we need to do that. So you basically say, 192.168.1.45. 552.552.55.0. I know my gateway. Here. Copy paste, I like better. 2. So when we download this, it will make this card have an IP address of 192.168, just like these settings here. And then we go to the port configuration. We'll do this auto. The big thing here is that if you're going to manually assign it, like manually assign whatever you want here, that you need to match what the master is. Okay, so meaning this. So right here. Port config. So when you're online here, you turn these on so that it's auto negotiate. It's probably defaulted to that, and then it has to match the controller. If it doesn't, you might have some issues. I've run into some issues in the past. They basically have to match. It's that simple. And then there's the factored group. So the encoder that is inside the motor, it is a incremental encoder, whether it be absolute or not. It's irrelevant. And it provides pulses, and the pulses need to be determined or be transformed into units of measurement that you want to use in your project. So this particular project here, where is it here? Measurements. So we're in a linear and we're using metric, and we're going to say we have 3 decimal places for everything. Okay. And this here area turns the pulses into the units that you want to be transferred over the communications. So everything's a whole number coming across. So when you select exponent to the -3, and you send 10,000 as a position target, for example, then this controller here will interpret the 10,000 as a 10.000. You will also get a feedback over the communication or the FHPP, and it's the same concept. You send 99, or if it's at position 12.32, then you'll get a, well, you get the idea. I'm a little tired right now. So the next thing here is the really important factor here. If I go into a project, which we've configured, go into the FML read, you've got this field right here, this config FPC. So in the world of the FTT, you have the first 8 bytes of data here. So this is 8, 16, 24, 32 bytes. And the first 8 bytes of data is called FHPP, Festo Handling Position Profile. And that 8 bytes is used to control the access. And there's a send and receive, basically, message to and from the PLC. And then you have the next 8 bytes that when you turn this on, it takes the next byte, and they call that the Festo parameter channel. Again, it's the read and write. So now we have 16 bytes, and we're using the FPC in the controller. We've said that we were using FPC, and it starts at the second 8 bytes. Now we've got a done deal on that. Move on to the next field. So in direct mode, so in direct mode position, you have a ability to use or to send the position target and also the velocity. The velocity is expressed in a percentage, 0 to 100, and that percentage is based upon this value right here. So if I make this 1,000 and I specify 50%, then it'll be 500 millimeters per second that move will take place at. The accel and decel are set in stone here, so all moves will take place at the values that are shown here. If you want to modify the position of the accel and decel later, then you get a little more advanced. So I'm just going to accept that. We're just doing some basic things here. Hit the next button. Now we're configuring jog. Not that we need to do much there. The record table we're not using. Error management. Read everything here and determine what you want to do. Basically, you turn on the dynamic help here. It gives you some things on the right hand side. So you've got these things right here. They explain what the top fields are for. Like if you're in the middle of a move and you encounter a following error, which is this move right here, then the default is quick stop. So as we explained earlier, wherever that was, where is it here? I think it's right here. Yeah. So quick stop. See how this says quick stop? We've got a deceleration of 5. So in the encounter of a following error, it will automatically quick stop the axis. So it'll stop the axis at 5 meters per second squared due to the fact that there is a fault. If you were to click this off as a warn, then it won't do anything. It'll display that you encountered a following error, and it'll keep doing whatever it's supposed to be doing, or whatever problems it encounters, it's just going to ignore it. If you hit this one here, it ignores it altogether. You don't even know that there's a problem. So it's important to read what these are and understand hopefully what they are and configure the way you want to suit your application. If you forget what you've done, you can always hit the default values. Away you go. And the trace we don't need. Trace is like a scope. It'll track different things when you're tuning or when you're looking for some problems or whatever. And that's it for the configuration. The save button, and we have configured everything to do with this card here, and we've configured everything that's attached to it, and we would basically go online. So how do we go online? Well, I don't have a controller here to go online to. Basically, the first thing you need to do is set up the FCT interface. So the interface is how are you going to download to the controller and communicate to the controller. And the options you have are you have a USB port right here, right above the Ethernet port, and you've got the Ethernet port. So if you've installed the driver for the USB, then you would come in here and FCT, select USB, hit OK. And then the next time you click on this button here, it'll go online and search for everything connected to USB, and you'll find it, and now you've got it configured and it'll go online. If it's Ethernet, then you come into here, go down here, and then you come down here, you do a scan. I have nothing here, but a device would come up here in this area, and then you would right click on that device, and you can select IP address and modify the IP address. Of course, you do not want the same IP address that we've already chosen for this card, so 45 was that card. So in my case, I will make this port here a 1.44, and you'll hit OK. It'll be occupied as 44, and OK. And then the next time you click this and go online, it will go online via Ethernet and ask you to download to fresh controller. The last thing I'd like to explain in here is that you've got a couple buttons over here. So if you go online and there's existing code and it doesn't offer you the pop-up to download or store or anything like that, the buttons over here, which are grayed out right now because I'm not online, these allow you to upload, download, sync, and store. So what are these buttons? Upload. So the controller has a project. You want that project to be here. You say upload and follow the directions. Download is where you take this project file we just did, download it. It's now stored on the volatile memory. So if you were to cycle power to the controller, which you normally have to do in order to modify communication settings and whatnot, and so the cycle of power happens, and now the controller is back to where it was before you download because you didn't do a store. So brings us to the next one, the store. So get used to this. The store basically permanently puts the controller program into a double EEPROM, and that way when you cycle power, it's still there. It's going to use that on the startup. That's pretty straightforward. So when you're using FCT, get into the habit of just doing a download and store. And that's it for this part of the video.
So the next step is to do the online monitor / downloads. So we've got our FCT project. We've selected our FCT configuration. Scan all the drives. We get nothing. I guess we have to turn the drives on. Do another scan. So there's this axis right here. So this is the one we want to deal with. It's already had an IP address assigned to it. If you don't like the IP address, you can always go in and change it right here. That's the port X18 on the face of the unit. That's not the Ethernet IP port, but the actual programming Ethernet port. So you select your axis, you go, so now you're selected, now it's configuring the project. Now you click to go online. might be mismatches. You do a download. This particular motor controller I have here has got a STO card in it, and there's some dip switches on the face of that, and the bottom dip switch is to the left, which basically activates the Ethernet IP card that I have installed in the right-hand bottom slot. So slot 2, which is this card right here. So now the program has been placed on the volatile memory. Now we do a store. And because we've changed Ethernet, maybe it was previously can't open or something else for whatever I was doing. At this point, just do a restart controller. It'll cycle power, you will hear a little click. It'll come back online, should give you a good status update. And at this point, you typically want to make sure everything is correct and so on and so forth. So this is where we did our IP address for our Ethernet IP card, and it's reflecting that right here. This right here shows you the firmware that we're using and the hardware and the card number and so on and so forth, and anything else that's online. So I'm just going to quickly go through each page so that you have an idea what we have online. That's it for there. Now this area at the bottom here is the commissioning area for the drives. And we have not downloaded the PLC project yet, but that's not necessarily required as of yet. So to take the control sovereignty, you can turn on this FCT checkbox down here, turn on the enable, and as long as you have the hardware enabled, so this DIN 4 and 5, if you were to look at I/O drawings, let me just grab a PDF for this, hang on. Okay, so I have this drawing here that I've done, and it basically shows you the pinout. So when you're looking at the very top of this controller here, at the very front, there's a 25-pin connector, and that is what they call the I/O cable. This is what it's reflected. So the blue here, the DIN 5, DIN 4, so the designation here in the middle, that's what you'll see in the FCT configuration. And it's basically DIN 0 through 7 over here and 8 through 13 over here. So DIN 4 is the power end stage, DIN 5 is the controller enable. Those are hardwired, they need to be activated. If you don't know how to wire them properly and wire the STO, then talk to tech support and get a good idea on how to do that. The limit switches, the over travels, are DIN 6 and 7, so we need these here as a minimum before we can actually get the software enabled to turn off and on. Okay, so enable's on, power stage is active. So now we've got our DC bus voltage coming out to the motor, and we've got our STO circuit, or 2 channels, active and okay. The first thing we would do, this particular motor has the M, so it's a multi-turning motor. So out of the box, these motors from Festo come with the homing valid on, because they're an absolute, there's an absolute encoder included inside the motor. It's good for up to 4,096 turns, and it's up to the user to configure it properly when you put it in the system. So there's a real simple thing on that. So I'm just going to home the axis, which is right here. So it homes, it hits the limit switch, And then it asks you, do you wish to save the offset to code? Yes. So at this point, it's offering you to store the offset in a chip on the motor itself. So that so it disables the motor. It does things automatically in FCT. So it's storing the offset now, and away you go. So if we were to cycle power right now and come back in, wherever the axis is will be absolute, meaning it'll be wherever you left off until you do another home and so on and so forth. So the you always have this offset to save offset to encoder. The old way, it didn't offer you automatically in the older plugins. This plugin down here is 280554, and the FCT, which is like a shell that the plugin gets installed on, is the 1236. You used to have to do the save offset yourself. So we've got the operate, the status bit right here, the dip switches, as you see here, the bottom one's on. Safety functions are okay. We've now homed it. You can come in here, you can jog the axis, it's now jogging, and so on and so forth. Away you go. And the other thing you can do is some relative moves here. If I put in, I don't know, 100, tell it to go at, let's say 50 millimeters, hit the forward, it'll move 50 millimeters forward as a relative move. I hit it again, it'll move forward again. Change the velocity, move back, and away you go. So that's another thing you can do here. If you want to perhaps execute a couple of moves down here, you could add these. Say cycle and say run the sequence. So it's going to just run through these sequences over and over again. It's going to stop that. Say we continuously go. You could add delays between the moves and things like that. Optimize. This is specific what these is really for. You typically make it go back and forth, and then you play through gains. But the gains are typically pretty tuned in the first place. I'm pretty impressed with that. Memory card we won't discuss. I'm going to say turn that off. Diagnostics. Read all entries. So I've had a positive, I've had this, and then you can read the positive faults as well. And you can export this. So you can look at all your faults and everything there. And then we get into monitoring from the HMI. So that's about it. We're finished in the FCT area, and now we're going to move into the PLC. So I'm going to go back to the PLC program here in a second. And before we do that, we're going to turn off FCT because you need to gain the control sovereignty back in the PLC first. Okay, so we've got the PLC open now, and we're going to select controller here. Set the project path so you don't have to do this again, and do a download. Overwrite anything that's there. Go back into run mode. Okay, so we're online now. Just going to close a couple of things here and go into this routine right here. So, okay, so let's talk a little bit about the actual FHPP. So, well, actually, let's just talk about this. So we've downloaded, and the first thing we want to verify is that we're up and communicating. So The module here indicates that we are running without any faults or errors. Got a unicast, cyclic, 5 millisecond, copy IP from general. Port. And for some reason, I'm only communicating at 10. Or sorry, on port 2. I'm on port 2. I'm on the top port. And I'm running at 100 megabytes. And we're not in a ring network. So that's all good. And as we see here, we've got no errors here either. And now we can see the relationship between the, this happens occasionally here, the EthIP connection closed. You can clear that by doing that in FCT or doing it here. So this reset fault. So there's a fault over here on the right. If you put a 1 in here, reset the fault. Fault's off. Fault should be cleared in the controller. And it's cleared, yep. So we've got message to and from the PLC. So the VLoad and reference are on in the PLC, or in the controller, and therefore homing valid and load voltage applied should be on here. So there's your status. So I come into here and put a halt on, and go back to the FCT. Halt is on right here, and so forth. So we've got communication up and running. I'm going to give you a quick blurb on the bare minimum of running an access. So maybe I can do something where I can see this over here. So right now I'm going to have you focus on the power stage. So halt. We need to stop, and we need to enable. So as we have those, you have the power stage active, and the PLC is now in control. Now, another key point is that if I now turn this on, I've now dropped out and have the control sovereignty in the FCT. Turn this back off, and it gets it back in the PLC. Sometimes on some controllers and firmware, if you've had the control in the FCT and you do some movements, let's just do something real quick here, see if this is still a thing, and then come back, turn off that, turn off this, power stage comes on. Sometimes the power stage does not come on, and at that point in the PLC end, you have to turn the enable off and then back on to get the control sovereignty back. So that's the key point to think about on different revs. Yeah, let's do a move. So there's two modes of operation. There's record mode and there's direct mode. Record mode is, as we say here, 0 right here in this field. And in order to execute a record, you put a record number here. Let's say record number 4. And you put a start task in, and it just moved. As you can see here, it executed record number 4. Target's 150, which is like this one right here. When you're actually coding in the PLC, the sequence of operation is, turn on the start task. You'll see here that you have an acknowledge start right here. That's your handshake to say it's being done. At that point, you turn off your start task, and the next thing that you're going to be starting to look at is your motion complete. Only after you've turned on the start task, got an acknowledge, do you even consider looking for motion complete. Don't use the motion complete, simply it going off and then coming back on, because it won't work for every move. That's the proper sequence. Okay, included in the Dropbox zip file that you'll see that there's a link in this video here to all the stuff that I'm dealing with here. You'll see that there's a power stage and position control sequence timing chart. Okay, and this talks about the I/O signals, the digital input, 4 and 5, how they have to come on sequence, and so on and so forth. And then on the following pages, it refers to the variety of signals that are required to do a move, and in record mode, and then direct mode. Okay, so it's important that you understand this, because this is what you're going to do to code your PLC with, as far as structure. And Festo has this 804-6788 document that is called the FHPP document, and it discusses all the different settings for different field buses, talks about the ports, provides the diff switch status for enabling for the IP address, and also discusses the actual data map. I think it's 124. Okay, so in here it discusses the first 8 bytes and how they're used for record selection, and then the same thing in direct mode. So the first 2 bytes of information, they're used to manipulate what modes of operation and things like that are, and it makes these other bytes and integers resemble what's required for each mode of operation. And then the document here explains in a little bit more detail, and then gets further into detail here. I've got a layout summary. It's from the same book here, and this will also be included. And basically there's a control and status area, and there's a parameterization area. And the control area is the first 8 bytes, and within the first 8 bytes there's 2 distinct modes. There's record select and there's direct mode. And the direct mode has a couple other sub modes, which are position, force, and velocity. I'm only going to talk about position, and these just break it down even further. This talks about control and status areas, this read and write. It gets into real details, put some color function in there. If you're in direct mode, you'll see here that these bits up top here select the mode of operation, like direct mode or a record. These ones down here select the actual mode within direct mode, so position, force, or velocity, and then depending on what you've selected there, these mean a variety of things down here in this area here. So you can look at that book there. It's going to close that, close this, close that, go back to the PLC code. Okay, so I showed you recently how to do a record. Now if you transition this into 1, turns it into operation. There's your acknowledgement that you're in that mode. And at this point, you're in direct mode position, and this value, set value velocity, is a percentage of this value here. So I'm going to put in 10%, which should be 100 millimeters. And in the field bus, we have a factor group here. I've got to the exponent -3. So if I want the axis to move to 10 millimeters, I would put in 10 and then 3 decimals. And let's see if this gets a little bigger here. Maybe it'll be better for you. And again, same idea. This would be, of course, done quicker when you have code, but basically I'm going to put on a start task. It puts the target position there. You get the acknowledge start. The acknowledge start goes off, and then you're looking for motion complete. And that's it. The thing works, it functions. If you want to jog the axis, put a 1 in here, and it will jog as long as that's the 1, and turn it off. that in there. And there's a couple other things that you can play around with. Well, I hope this video's helped for you, and enjoy the Festo product. It's a good piece of hardware. Thanks. It was done, but I'm going to go into a little bit more advanced here. So what I've done is I've actually elaborated on the PLC program that at one point only had a couple of function blocks or AOIs, and I've added the remainder of the AOIs that are available. You know, there's quite a few, and I've added some code to act on those AOIs to follow like a sequence of events and so on and so forth. So I'm just going to download this, and I'll take you through it quickly, because this will be the same PLC program, except it's called moves yes in the name of the PLC file. The first one was move no, so it was just basic information. So this piece of snippet of code, like I said, it's going to show you position mode moves only, both direct mode sequence and record mode sequence. Yes. Okay, so we're online, and the first thing to note is that I have this bit. It's a programming bit, I'll call it. Toggle the bit off and on to either ignore all the code that I've added or use the code. So if you turn this on as standalone here, same bit except different location, that means that you can manipulate these values yourself. You know, you put a 0 or a 1 in there, and if you turn this back on or off, sorry, then these bits are being controlled by the codes. So for example, the mode select, you're in direct mode, and enable. So these bits here are being turned on by code. I've added a data type. There's a data type that's part of the control here. I'm using that to do the programming in a structured manner, so that you've got the one tag here for one axis. Okay, so if you wanted to duplicate this code, you would you know, take this, rename the tag here to something unique for one axis, and then rename the routines, then drag it into a new project, and you've got a whole new axis. Way you go. And the only thing you would have to do is to change this right here for the input data, and if you go to the end here, change this for the output data, and away you go. Okay, so mode select, we've got record and direct mode. This is just left for future here, the mode for speed and torque. So I'm in direct mode. If I want to do record, I would Control T or toggle bit. So right now I'm in direct mode. It in turn set to 1 in the operating mode, which, you know, right here is the operating mode right here. So it's setting a 1 there. If I was to change that over here back to record, then it's setting a 0, and this is 0 over here. Okay, so for now we're just going to talk about direct mode, and you don't have to have all these routines. Obviously, I put this here for demonstration purposes so that you can do your own code. This is the sample only, and these are all bits. You know, there is some error recovery sequence data in here, so I'm saying I've got a gate's okay and e-stop's okay, and then this one here is just for me. I just turn that on to create a drive ready. If you go down to the, just gonna get rid of this for now. If you go down to here, you'll see that the drive is enabled, but we have a fault. So we need to come down here, and we have the fault. So Control T, toggle it, turn it back off, goes to a warning. What is the warning? Conditions for controller enable. Okay, well, it's gone. So it cleared itself. And prior to any move, this is a rung that I call a safety rung. You need all these bits active and this bit high in order to have the controller ready for a move. Meaning, you know, the drive's enabled, the homing's valid, Load voltage, you're ready. The axis is not moving. The HMI, which is the FCT button or the checkbox, where is it? This checkbox here is not turned on, and you have no fault, no warning. Okay, and I've got a little bit of a canned package here of code. Basically, Control T starts the homing sequence. When it's finished, you get a homing sequence complete. And if you want, you can start it over and over again. So that's the homing. Shows you that you start the homing, make sure you're not faulted, get the homing valid, and so on and so forth. So now we get into the sequence. So the direct mode sequence. So direct mode moves. Okay, so let's work backwards a little bit. So just close all the windows here. Close all. So direct mode moves. Basically, this is set up like an automotive type 5-rung thing, code snippet for each move. This rung right here is entirely up to yourself. I'm not using it. It's just there for demonstration purposes. So you could call this a 3-rung code. Basically, you got a sequencer. The sequencer turns on the precondition. As long as you're in auto mode and the cycle has been started, whichever, these are just bits you toggle. You can put your own stuff behind it. And you're not in recovery, you're not active, and you get your safety. And basically, at that point, you're going to shove a speed percentage in, a target value. It'll set the command gets turned on. It'll go out to the common control here. So the command and not active is going to send the start task. The start task is going to set the start task right here. And you'll wait for the acknowledge start. When you get the acknowledge start, you latch in that you're active, you unlatch the command. And once you're active, you wait for the acknowledge to go off, because that's the way the code is in the common area. And you wait for the motion complete. When the motion complete happens, then you're complete. The move, this specific move is finished. I just have 6 moves set up. I just, different velocities, different position targets, and away you go. It's that simple. And the sequencer, this bit right here is just to reset the sequencer in case something stupid happens. But basically, when you turn this bit on, it's going to start doing its movements. So if I go to my FCT, you'll see here that it's shoving new values in the target, doing its moves. And you'll see that the sequencer right here is basically, it just falls through here. And when the whole sequencer is done, it resets the moves. Very simple. Again, just for demonstration. Many people do code differently. This is just to make things really simple that people can understand. And to turn the stepper off, you turn this off, toggle the bit, Control T, and you can reset this bit by resetting that whole thing. So same thing goes for record mode. So Control T, get into the record mode, and go to the record sequence and moves. Same idea, except all we're doing is we're shoving a value, which is our record number, into the controller, and same events, meaning you will eventually turn on start task, get an acknowledge. Now you're active. Once you're active, you're waiting for the acknowledge start to go off and the motion complete to come on. You get a motion complete. Very simple, straightforward. You, of course, need to have programmed the record table with 6 moves, which I have. So all I have to do is come over here, turn this bit on, and it's going to start executing the moves. And that number there tells you what move you're doing. I should just go 1 through 6 and then start over and over again. Those are all the different moves. And this over here shows you that it's executing. Very simple, straightforward moves. And you want to shut it off, just, Control toggle, it'll finish and not repeat itself. And reset itself. So there you go. And there's the sequence recovery bit, whether you care to understand how it works or not. Basically, if any point, if you drop the gates or e-stop, the code is designed such that when you turn the gates or when you reset the gates or e-stops, and both are okay, then it'll pick up the last movement it was in the middle of and continue on its way off and running. Okay, so that's the simplicity of it all. This here, again, is more just common code because we're shoving target values in, multiplying by scaling factors to match the scaling factor in the PLC. We're getting position actual here. Again, dividing by the scaling factor to get actual position. And this one down here is so that when you're programming your record mode moves, that this percentage value doesn't go below 0 or above 100%. This just, puts it either at it trims out the min and max values basically. And I hope this helps.